I'm going to introduce you to the 3 gas laws that we covered on the second block day, so on March 7th and 8th. The first one is Boyle's Law, and this is on the paper you guys got in class, and it says the gas law is section 13.1. So it's section 13.1 in your book. Okay, so Boyle's Law relates pressure and volume. In these problems, temperature, the third kind of thing we look at when we're doing gas problems, is constant. But pressure and volume are looked at. Pressure and volume have an inverse relationship. So that means if pressure goes up, volume goes down, and vice versa. So inverse relationship. And then the equation we use, this is technically what is Boyle's Law, is P1 V1 equals P2 V2. So if you're given a pressure and a volume, you can multiply them, and then you can solve for either the second pressure or volume. Okay, moving on to Charles' Law. Charles' Law relates temperature and volume together. In these, pressure is constant. Temperature and volume have a direct relationship. So what that means is if temperature increases, so does the volume. So this is called a direct relationship. And the formula we use for Charles' Law is V1 over T1 equals V2 over T2. And our third gas law that we talked about so far is Gay-Lussac's law, and that relates pressure and temperature. When pressure and temperature are looked at, then it's assumed that volume is constant. Pressure and temperature also have a direct relationship, so that means if pressure increases, temperature increases, and vice versa. And so its equation looks very similar to Charles' Law, except instead of having volume on the top, we have pressure on the top. So P1 over T1 equals P2 over T2. And as far as example problems go, I'll post videos for solving one of the Boyle's Law problems, the Charles' Law problem, and the Gay-Lussac's problem. All right.